You did?
No.
Where's the laptop?
Mine.
Oh. Okay. I just set it up because. Oh, he did. It's already set. Yeah. Can you see me? I forgot there's people online and I'm just goofing around.
As questions come in, do you want me to let you know when or do you have questions there? Well, I think we're going to talk about it. Okay. When I get that file, I'll come make sure that you know. Okay. And if there's a question, is this your stuff, Matt? Oh, we can see the key. Just trying.
Have you been? About 3 months. That's good. Basically. So, yeah, no. I'm slow. That's good. Right Software, primarily. Here.
I guess timing I can start on here in the this has been open for 20 minutes.
Right. So
I think we'll get started.
I think we'll get started. Looks like most people have kind of transitioned in, and hopefully the live stream is up and running. Good. Okay. All right. So my name's Matt Tanner. This is Johanna Marcelia. We're both we both work at Natural Intelligence Systems here in Boise. We're excited to be able to talk to you, to kind of speak about machine learning, artificial intelligence, a little bit of our journey into this. So, and enhancing the customer experience, right? Creating a better customer experience. Now, the first thing I want to do when we talk about the customer experience, a better customer experience, is maybe ask what's wrong with what's happening right now. Let's give a little credit to AI today, right? There are some really amazing developments that have occurred up to this point, right? We've got it seems like every day there's a new announcement of a new way to use machine learning or artificial intelligence to do something to improve our lives in some way, right? Tremendous strides have been made in autonomous vehicles, image processing, diagnostic systems, other specific domain-specific applications. So what's wrong with where we're at today? Why don't we have what we would call a good customer experience? You know, when I think about what's lacking, there's a couple things that I could point out. First of all, how many of us at this point are really willing to use artificial intelligence in a high-stakes scenario? Right? It's just a little difficult to trust these systems. Now, Johanna's going to talk a little bit about maybe why that is. But the second point, AI today is very power hungry, very compute intensive. It takes a lot of time and power to train these systems. It takes a lot of data to train these systems. And then when these systems are deployed, it's difficult to get them where we'd like them to be in terms of out on the edge, right? So there's another aspect that could be improved. We live in the world of big data, which is great, but when somebody goes to train a machine learning system today, you need a lot of data in order to do it. And if you're not Google, where are you going to get that data and make sure it's good data, quality data, clean data? So there's some difficulty there. And our current AI systems can be really frustrating to use too. They're supposed to help enhance our experience. But let me give you just a quick example, right? I pick up my phone, dial in the number for my bank, and I actually use two different banks, right? So one bank is great. A human answers the other end of the line. Communications flows nice and easily. Things get done. When I call the other bank, it's a phone system, right? It's an automated phone tree. And it uses AI. There's voice recognition behind the system, but me as a user, I've got to constrict my vocabulary way down, right? I'm only allowed to say one of the 10 possible digits. I can always throw out the lifeline representative, right? And sometimes I go straight to that, but I have to adapt myself to that system. It can be difficult, it can be frustrating, it can be kind of a mess. I have to be really vigilant that I don't cough or clear my throat or something while I'm on the phone. These could be mistaken as inputs to a system that's supposed to be friendly and easy to use. So, all right. With our presentation here, we're going to get into some of these hurdles that we see in today's world, and maybe talk about some of the underlying reasons that they're there and how we can overcome that. First, though, I want to throw out that if we want to be able to improve the user experience and build a better user experience, we're going to need to develop new technology and be willing to leave a little bit of tradition behind. So think about how technology has always advanced. You'll have a system, the status quo, and people will make improvements to it, make it more efficient, better, faster. But improving the current methodology doesn't always give you the results you want. I got up this morning, it was a little bit cold, in fact, right down in the 20s. And I thought, I'd rather be in Florida this time next week. That'd be kind of nice. How many of you guys would like to go down, be somewhere warm? How am I going to get there? How are you going to get there? Right? A couple hundred years ago, it was a horse. It was horseback, it was a carriage, it was right? That's what technology was. And at the time, people probably did focus on, we've got to breed a bigger and better and stronger and faster horse. And then somebody came along with a crazy idea, right? I'm going to take an engine and I'm going to strap it to a metal frame and I got to put wheels on it. And it probably seemed crazy at the time, but now the automobile is something all of us use every day, right? So most of us are not going to drive to Florida though, right? How are you going to get there? Most of us will buy a ticket on an airplane. If I'm technology advances by taking these leaps and bounds, and we need to be willing at some point to leave tradition behind and look for a different way of doing things, not just making the current way faster, more efficient. So, go ahead.
All right. So with this idea in place that tradition is something that as we move forward in technology, we're going to need to kind of circumvent or move beyond, let's talk a little bit about what today's AI looks like and what past AI has looked like. And often it's easy to divide historical things into different categories, so I'm going to be speaking about these in different phases. So the very first wave of AI, or phase of AI, is characterized by a couple of different things. Specifically, these types of models were really good at basic reasoning, but not learning or generalizing. And early AI was very focused on human rule-based algorithms. So unlike a lot of the AI we might use today, for these types of early systems, a subject matter expert was actually the one deriving all of the rules and internal logic of the algorithms. And they had to be an expert in the data that they were characterizing. So some of these very early AI technologies, we consider them to use more traditional, maybe mathematical or logical methods. And I've got a couple examples of these, and hopefully these are familiar to most of us, right? We've got our very early online games, some basic, checkers and chess. We have maybe some of you or your children have used Furby, right? Early robot technology, not very advanced, but relied on those very basic algorithms. But not all of them were simplistic. Some of them could get quite complicated. And if you are familiar with the Enigma cryptography device that was used during World War II, that was quite a complex, very rule-based system, but still falls under this category of this first wave AI. And just because these systems were very simple and compared to some of today's systems, doesn't mean they're not still useful. We still have things like diagnostic tools that operate in this method, using this method, where you can input some symptoms, maybe that you're physically experiencing or that your car is experiencing, into a simple program, and it might give you an initial diagnosis, right? So this is kind of the first wave of AI. And timeline-wise, this was from about the 70s, maybe earlier for some of these things, right? But the 70s to 2000s is when we would kind of had the first wave is happening. And then we saw...
Matt, the camera's following you, so if you just want to move out and speak a little bit, then it will...
Thank you for letting us know. It's an auto-track camera, so I'll try and get it to have me in frame. Hello, camera. Okay. Yeah, first wave AI, come follow me. Okay, so with the first wave of AI, this is kind of, it has a limit, right? There's only a certain level of complexity that it could handle. And so in order to progress further, these very traditional, more simple algorithms really did have to be left behind so we could derive what we would consider our second wave AI systems. And these are probably more familiar to us today in 2022. We have models that are excellent at learning. And not only this, but these models derive their own rules from the data. So you don't need a human being who's an expert in the data to be the one telling your model how to interact with the data. But instead, the model for that very specific data set does a bunch of statistical analysis and mathematics to come up with its own rules. Not only this, we can handle text, we can handle speech, we can handle images with these more complex models. Specifically, the model that is most popular today would be the neural network model, which I expect many of you are familiar with. But this type of model is light years ahead of some more traditional models in terms of complexity, which means that it can handle these very challenging scenarios that first wave AI really had no chance with. And so, like I said, this is much more common in our day-to-day life, and I'm willing to bet all of us have engaged with a second wave AI system, if not today, well, yesterday, probably. So here's some examples. If you've got any kind of smart technology in your home, like the Alexa, something like that. If you or somebody you know drives a Tesla, that absolutely has a lot of these third wave models in it. And maybe you don't have a Tesla, but you have some other navigational software you might use to get around town or to find, the parking garage. That uses third wave AI. And if none of those apply to you, anytime you make use of a search engine like Google, or maybe on YouTube you're searching for a video or something of that sort, second wave AI models are what power those and what allow them to offer helpful recommendations, right? So this wave of AI is from about the 2000s to now, right? And Matt and I, we would posit that we are on the cusp of our next wave of AI, the third wave of AI. We'll get into that a little bit more later, but one might wonder, okay, clearly the second wave that we're in, it's offering a lot of development. It makes consumers' lives so much easier than they used to be. We have all this technology at our fingertips, and that is true. It's very, very good at things that previously were impossible, right? It can discover and extrapolate all kinds of mathematical patterns in the data. It can classify extremely complicated data, including, like I said, images, sensory data, languages, all these things that are very hard for us to put manually into a very like traditional mathematical type of parametric algorithm. And it also can handle massive amounts of data with tons of features and categories and all kinds of complexities. But there are some major drawbacks. And as the second wave technology has matured, several challenges have arisen. And these challenges are ultimately crippling the customer experience from what it could be. So with these second wave systems, it is very difficult to correct and retrain them efficiently if there's an error that's present in the way that it is computing. As Matt mentioned, it's almost impossible to achieve high accuracy with small amounts of data. So for many consumers, making use of this type of a system is fairly challenging because providing that type of data is almost impossible. Oftentimes also these models can have hidden biases, but we can't really examine them deeply because they're so complex. Maybe you've heard the term black box used to describe a system, but essentially it means that the internal logic, it's inherently scrambled in such a way that you cannot follow from input to output or from output to input. So if there's a hidden bias in the model, you cannot identify it until it makes itself apparent when the model's been deployed. And also, computational efficiency is a huge, huge challenge. And this is a prohibitive thing for many people who might otherwise like to include AI or might like to offer some sort of AI to their customers, right? Okay, so what's coming next, right? We started with our basic rule-based, determined by human being kind of algorithms. Then we moved into our very statistically, computationally intensive models that learn parameters by themselves for a very specific narrow data set. And in the third wave of AI, well, we're going to hope and see that it can be more generalizable and function ultimately more like a human brain can. So what does this actually kind of mean? Well, here are some things that third wave AI should be able to do that are going to improve what this experience could look like for all of us. Third wave AI should be able to generalize to new settings. Think about when you learn to drive a car, right? You can drive your vehicle, and then does that mean that when you go and you're trying to drive a different type of vehicle, maybe a golf cart, maybe a truck, maybe a go-kart, that you need to fully relearn the driving process? No, you can generalize what you learned, driving a car at 16 to driving in a different environment. But today's models aren't able to do that yet. If you were to put self-driving technology from a Tesla into a golf cart, the algorithm would fail because second wave technology is only able to apply to that very narrow scope of what it was trained upon. So in the third wave, we want to see, or we're expecting to see models and algorithms and processes that can expand from beyond just the subject matter they were trained on across similar situations, just like our brains can. Third wave AI also should be explainable. When you're asked, hey, why did you make this decision instead of this one? You can probably offer some level of rationale, just like an algorithm should be. So we want to remove that black box layer from these models. It should require less data, right? And importantly, as we've seen, as these models have matured, it cannot be accomplished by our very best technology today. And so if our brains are able to do these things so easily and so instinctively, why is it that our systems now really struggle in this area? So just keep that thought maybe in the back of your mind. I want to talk about a couple of these concepts in a little bit more detail, just so we kind of understand how not having them is making the customer experience worse, and maybe how having them could really improve things for future customers who want to employ AI. Okay, I want to start with a little story here. In 2019, one of our leading tech companies, Apple, released a credit card, okay? Being a tech company, they're like all for employing the latest and greatest technology, so they used a complex second wave algorithm to establish credit limits. So not with human oversight, they're using an algorithm. And it quickly became apparent that for a number of consumers, men were getting approved at a much higher rate or amount than women were. The limit seemed vastly different for those two groups, which of course is an issue because of various policies and laws, right? But because Apple was using this advanced technology and essentially was employing a black box algorithm, they had not only nothing to tell their consumers about why their algorithm was screwing up, except for, it's the algorithm, we don't know what went wrong, but they didn't even have a chance to catch this error before it was deployed until it actually started impacting people and making them angry in this case. But to Matt's point, if this type of challenge occurs in something as, I don't want to say credit cards are trivial, but in something as trivial as a credit card, and we can't explain what happened, it shows how difficult it can be to trust artificial intelligence with decisions that maybe involve human life, or maybe in a more serious way, our finances or security, things of that sort, maybe safety. And so explainability is a very important component of this next wave of AI. We need to be able to remove that black box, see that internal logic of the program so we can know why it's making the decisions that it's making. Just like a human could do this to some degree, if a person instead of an algorithm had been setting credit limits, you could have asked them, right? Oh, why did you give them a $10,000 limit, but they only got a $2,000 limit, right? And they could say, oh, well, because of these factors, right? So this is something we really need to see in the next wave of AI, and it becomes a bigger and bigger problem as we try and create algorithms for more and more high stakes scenarios. All right, so that's one factor. Let's also talk a little bit about the concept of kind of continuous learning and being able to generalize as we see new things. Okay. So suppose you had developed a product for a customer who produces fruits and vegetables. So we've got 4 different categories of fruit that they produce, and you've built a great application for them. You've got your model, you've got a beautiful, interface, you got it working really nice and fast, and the graphics are great, right? Okay, so the client's very happy with this, and it categorizes perfectly the 4 types of fruit that they produce. But they call you up one year and they're like, hey, you know what, we're gonna start also producing avocados. Now, even if you had never seen an avocado before in your life, you could look at that and tell me instinctively that it is not one of these other types of fruit, right? Yeah, okay, good. But for your model to function with today's technology, today's most prevalent technology, you would need to pull your model offline, collect a bunch of avocado data, retrain your model, and then redeploy it. It doesn't have the ability to learn continuously as it sees something new, even though our brains are so good at doing this. We do this every day from the time we're born, hopefully for as long as we're alive, right? Okay, so say you've retrained your model, reset it up, all that stuff, and they call you up next year and they're like, hey, we're also going to start producing limes. Well, what do you have to do? Well, you've got to pull your model, retrain it from scratch again to include this new category. So once again, hopefully you can kind of see where this is going. It's not efficient, it requires a lot of data, and it functions in a very different way from our brains. And we know that there is that efficiency somewhere in technology because our own brains can do it. So this is another drawback of today's systems, and something that the next wave of AI, hopefully, we'll talk about soon, we'll be developing further. The last one I want to touch on is that the third wave of AI should be able to handle missing data and noise. Okay, non-rhetorical question for you all. Can anyone distinguish what this is a picture of? Yeah? It's a castle. Thank you. Yes, it's a castle. And you could tell that even though 50% of the pixels in that have been removed and replaced with just random colors, right? But today's best AI systems would not be able to correctly classify that. To be able to perform well on an image, you would need to have every pixel, or nearly every pixel, filled in with the correct value so it could distinguish it. So once again, we can see that there's kind of this disconnect between how well our brains are able to do and to generalize, to figure things out, versus what today's best technology can do. So again, if you're trying to create a model based on images, you need to have clear, pristine work that is, nice and not noisy and no missing values for it to function well. Okay, so these are just a few things that the third wave of AI is going to bring to the forefront. So hopefully that's got you a little bit interested about where this could be going, and I'm going to let Matt come back and take over the camera here and continue this conversation.
All right. It looks like it's pointed at me.
I think it is.
So I'm going to switch gears just a little bit, and I'm going to weave our company into this story, right? You guys are all aware of AI. You're interested in it. That's probably right why you came to this session, this breakout session. So our company, Natural Intelligence, started out as a small research group within Micron. Those are our origins. We were working on a research project, right, where we were using memory to build a highly efficient, very fast pattern processing device, pattern matching device. So in 2016, we parted ways with Micron. We left to continue development of this idea on our own. And our plan was to build this really fast, highly accelerated pattern matching device and use it to accelerate, right, and bring efficiency to all kinds of workloads out there. So that was our plan, and we were a bunch of pretty, smart, dedicated engineers who were pursuing this dream. About a year after leaving Micron, we had kind of a light bulb moment, right? The light bulb went off for us. We followed technology. We knew about artificial intelligence and machine learning, and it wasn't a focus for us. But then the idea struck. We've got a device that does pattern matching. And could this device somehow be used in the machine learning and artificial intelligence pipeline? Is there some way to incorporate a new approach to trying to solve this problem? So we started to lean really heavily into this idea, started to focus on it. And we spent a lot of time and energy. And yeah, we figured a way to take our device and to add some additional logic and so forth around it and create a device that we could present patterns to it, and it would learn those patterns. It would start to assimilate those into some common constructs, and then we could take it and go out and deploy it, right, in an inference mode, and we could present it with new information, and it would respond with the patterns we trained it on. It would start to recognize the things that we trained it to see. So this was great. We thought, okay, we've got a new opportunity here. We've got a way, we've got a new approach we can use to try to approach machine learning. So think about your brains for a minute, right? Do our minds run at real high clock frequency? No, they don't. Do we do thousands of, really heavy matrix math type operations as we are perceiving the world and making decisions? No. We're largely pattern-based thinking creatures, right? So, in fact, some brain researchers have gone so far as to say all our brains know is patterns. That's it. When you get up in the morning and you drive to work, you're looking at the road, you're looking at stop signs and other markers, you're looking at other cars, and you're processing that information in the context of what you've already learned so far in your life. You're doing pattern matching. So, all right. It made sense to us that a pattern-based approach to machine learning was a path worth pursuing. And so that's what we leaned into. That's what we started pursuing. It did take a lot of time and effort, but as we started building and testing against this theory, we started to discover that some of the difficulties that Johanna's brought up were eased quite a bit when we took this different approach. So let me give you an example. Noisy data. In fact, not just noisy data, completely missing data, right? Let's not say completely missing. Obscure data, where we only have a portion of the inputs. This is a common thing. In today's AI systems, you'll train it in a nice, clean environment with perfect data, but then you got to go deploy that device in the real world. And sensors get old and degrade and so forth, and you can have some sensors go completely out, and you are missing that information. You still need to be able to make good predictions. As we started using pattern-based inputs and processing things in this way, we noticed that we could tolerate much more noise than a more traditional system. So we could handle missing information in a much more graceful way. So in regards to continuous learning, we've been working and seeing that we can introduce new patterns to a device that already knows a certain amount of, has been trained on a certain amount of data, and it can assimilate that new knowledge without disrupting what's already there. So now, my point isn't, and the point of us being invited here wasn't really for me to get up and sell our company and what we're doing. I want to get back to the concept that we decided to follow a new approach. And by taking a step off the beaten path and not just trying to make the current technology faster and more power efficient, things that used to be problems aren't as big a deal in the way that we're approaching machine learning. So if you're going to drive to Florida, right? I still want to get to Florida. If you're going to drive to Florida, you're going to have to go over the Rockies, right? You're going to have to go over the Continental Divide. Eventually, you're going to get to the Mississippi. You're going to have to cross that river. And people have gone ahead of you, right? And there are roads that traverse through the mountains, and there are bridges that cross the Mississippi because somebody discovered those problems and created a solution to it. But if you're taking an airplane, what concern is it that you have to go over the Rockies and traverse over the rivers, many rivers, not just the Mississippi, right? Problems with a different approach, these problems that used to exist aren't such a big deal anymore. They're still there. And you have other problems you have to deal with, right? You have to worry about high altitude weather patterns and wind and so forth. But maybe the way that we need to approach machine learning and focus on creating a better customer experience isn't through trying to make current systems, the current approach to machine learning faster and more power efficient. Maybe it's by taking a step back and taking a different approach to solving the problem itself. So.
All right, so we think that the third wave AI is the direction that we need to head as an industry, because really until some of these underlying capabilities that are causing current issues are developed, there's always going to be some sort of shortcoming in the user experience, right? No matter how nice the graphics are, if an underlying model can't actually achieve something important to a client, that's going to create something that can be improved upon. And as we are experiencing today, new methods are leading to new capabilities. And ultimately, these new capabilities are leading to a better user experience. Now, in our experience, this is coming through a pattern-based approach because we are seeing that making great strides in developing third wave AI. Other companies are trying to bring this third wave to fruition maybe through other methods. So ours isn't the only approach, but ultimately the goal is to create new capabilities by fundamentally changing the types of models that we are incorporating into our technology. And as Matt said, technology progresses as we leave tradition behind. So we're excited to see third wave AI come to life and hopefully to maybe play a small part in this revolution. And with that, we would like to open it up for any questions. And if there's anybody who's watching this online who has any questions, we'll have those come through our question moderator. But yeah, thank you so much for listening to what we had to say.
So if you could, with natural intelligence, and what you took from Micron, all that time, what are you delivering today on your product?
Okay, so the question is, just repeating for anyone online, so starting at Micron and now being natural intelligence, what is the kind of product that we are trying to deliver today? Yeah, Matt, do you want to take this?
Sure, we're still focused on developing technology itself, first of all. We don't have a product ready, but our target is to actually create a silicon device capable of ingesting patterns, learning, and then being deployed and making predictions against patterns. So it'll be a lot like, from the outside perspective, it'll be a lot like the AI systems that are in use today. You'll use the data set to train it, you'll deploy it, and it'll go out and make inference and be used at inference time to make predictions. But under the hood, the way in which it's doing that is going to be completely different.
And will lead to not having those same drawbacks, right? So far less data requirements and the ability to explain the logic underneath the model, those kinds of things are what's going to really drive the value.
And you're kind of leading the third generation of AI. So, right?
We hope so. Yeah. Yeah.
So based on your technology, how would your phone interaction be different from what it is right now? So best case scenario, you deploy your technology, you have your two banks, you have a human, you have that.
Yeah.
What would that experience be different, or how would that be different?
Okay, so we're going to repeat the question. Based on the technology we're offering, how would the phone interaction Matt used as an example change and be improved upon today? I mean, do you want? I can answer this one too.
Well,
I would say that with current AI, you have to train to a very specific, pre-designed number of potential outputs that you can classify something as. So with Matt's phone system, you're limited to the words and digits that it's currently designed to take in. But with our model being able to learn continuously and pick up new information and categorize that as it comes online, there's a potential that in that scenario, it could understand and distinguish a larger array of inputs than just what it had been trained to determine. That's one area I think it potentially could, as it's developed, right?
Yeah, and that would make it a little more human in its response, right? If so.
Yeah.
So you might see the differentiation in your consumer experience to try to drive more customers and have more people being customers because of the higher experience or better services offering.
Yeah.
Value.
Right.
Exactly.
A better experience because the technology behind it is able to right,
function
continuously
more like
learn.
us. Yeah.
Function better in noisy or absence of certain data scenarios, etc. So, yeah, it should be a more of an interaction that we're accustomed to, right?
Yeah.
Better.
Less frustrating, right? I mean, how many people have hung up because the phone tree was so annoying, right?
Right. So we're not talking about just better voice recognition, but maybe more context awareness of what is going on, what the customer wants. So that's the kind of vision that we have, right?
Yeah. And not just us, but all of third wave AI, right? That's kind of where it's at. Yeah.
First of all, thanks for your excellent presentation. I like how you broke everything down into these 3 ways, and then how you're kind of using this approach of pattern recognition over kind of computation as you're kind of framing the story. But I'm just curious to kind of piggyback onto Jay's question. Are you all like far enough along to share any like possible examples of some solutions or some problems that you solved with this approach that you all are developing?
So the question is, with the work that we've done so far, is our company far enough along that there's examples that we can share, kind of showing how this technology works? Yeah.
Great.
Yeah. So we definitely do have that. We work on we've done some work with government contracts and things of that sort, showing proof of this technology and showing these third wave capabilities. We did not include these in this presentation, mainly for time's sake and because we didn't want to get too in the weeds of our specific model, and kept it more general for third wave AI, but we absolutely have some of that work that we've done previously for various companies. Yeah.
Yep. So it's come talk to us.
Yeah, if you want to learn more.
Yeah,
we're happy
we
to
can
share.
discuss.
Component right after the last person where they have their box lunches, so maybe you guys are available after the last speaker for feedback questions.
Catch us, yeah.
Okay.
Sure.
Yeah, sounds
Catch
good.
us in the hallway or wherever.
Yeah.
So-
We're at about 10:25, so I think the next thing is starting here. So thank you again for coming. Hope you enjoy the rest of the conference.
That is true. You were like, I know. We've never done it before.
And also to throw the camera also as well.
I know, right? There was a part in the middle where it was going this way, and I was like, how do we get it out of this loop? We need third wave AI to be able to tell which is who it's supposed to focus on, right? Yeah.
Yeah, it's fascinating. I'm sure you guys are probably doing contracts or probably come to you and like, okay, how do we improve pattern recognition for certain, military activities?
Exactly, especially for situations where they need some of those things that current models can't do, right?
Right,
That's where
right.
they're really interested.
So how does your pattern recognition distinguish from things like, I take that plastic tree and turn it upside down?
I
It's.
don't know that we've done that specific thing, but yeah.
Yeah, I would say for something like that, probably it's not better or worse than current models because they can, fairly well distinguish that type of thing. But let's see,
It's a-
if you gave it a picture of that and some of the pixels were missing, it might probably perform better.
Yeah, teaching a machine to fill in, or actually I shouldn't say teaching a machine,
How do we-
building a machine that can fill in some of the missing data.
Extrapolate from.
Yeah, extrapolate from partial data. Yeah, I think we do that better than other approaches. In fact, we know that for a lot of the models, simple decision tree, even it can't function in the absence.
Yeah.
In the absence of some, right, you can't give it partial input.
Yeah, if it's missing anything, you either have to drop it out or you've got to.
Or
fill
you've
in
got
those
to
values
provide
as
it like
best
an
as you can.
average value from other,
Yeah.
so
Yeah.
anyway, we're excited about the approach we take.
Yeah, it's a lot of fun, and thanks for coming to our little talk.
think that's the way like you said, the brain works.
Yeah.
Yeah. Different people's brains work differently.
So just
Thank
have them
goodness, yes.
on this in between.
But it's true, they all have the same stuff. Yeah.
So instead of Windows apps, I asked them to be.
All right, so
Next out.
I think you just need to exit out. and we're done.
All right, thank you.
And you would move
All right,
it.
and they said that gets deleted off, so. Where's the mouse? There it is. Oh, look, there we are. Oh, yeah, see, it's doing that thing again where it like moves back and forth.
It's searching.
Okay.
That's our presentation. Is that it?
What are you guys looking for?
All right, we'll just delete our, you said these get wiped.
Yeah, they get wiped at the end of every day, but you can delete it.
That's right,
It's
sorry. That's right.
clear from the bottom. I got a text message saying how awesome you guys were even.
Oh,
Yeah.
excellent.
Well, good.
Good.
I mean, I didn't watch it. I'll watch the recording later, but.
Thank you.
Yeah.
Well, I guess.